Again, good day everyone. This is my report on ultrasonic. First, we have an introduction. Ultrasonic came from Latin words ultra and sonic. Ultra meaning beyond and sonic meaning sound. So basically, it means beyond sound. The sound that is being referred here is the sound that is audible to human voice. So it should be beyond the audible human sound. Now, we know that a human can hear sound that has a frequency ranging from 20 Hz to 20 kilohertz. And by definition, an ultrasonic or ultrasonic waves or ultrasonic sound or ultrasound is a sound wave having a frequency above the audible range or above 20 kilohertz. Now, let's discuss some properties of an ultrasonic wave. First, energy content, which refers to a very high amplitude. Next, just like sound waves, it can be reflected, refracted, and absorbed. Lastly, we can say that ultrasonic waves can be transmitted over large distances with no appreciable loss of energy. This is why an ultrasonic wave is an ideal for navigation and distance measurement. Now, let's proceed to ultrasonic sensor design. Here we have an HCS 404 ultrasonic sensor. Now, the HCS 404 has two microphones. The first one is the receiver mic. The other one is the transmitter mic. These microphones are used in order to send the ultrasonic wave and receive the ultrasonic wave. Below, it has 4 pins. The VCC pin that can power the sensor using 5 volts input voltage, the ground pin, the trigger pin, which is basically used in order to trigger the sensor, and the echo pin. The echo pin is where you can read the sound wave that is being received by the sensor. Now, behind the HCS 404 sensor, there are 3 integrated circuits. 2 of them are operational amplifiers, which has the main function of amplifying the signals, both the transmitted signal and the received signal. And lastly, it has a microcontroller. A microcontroller is used to differentiate the received signal and the output signal of the sensor. Next is how it works. Now, we have a sensor which has a transmitter port and a receiver port, and we have an object. Now, our sensor transmits signals of ultrasound waves to the object. These what we call transmitted waves. Once it hit an object, we know that the ultrasonic waves are or functions just like other waves. It can be reflected. Once it reflects from the object going back to the sensor, it is being received by the receiver mic, which then the sensor absorbs, or it gets these sound waves. This is what we call the echo wave. Now, from the given scenario, we can measure the distance of the sensor to the object by simply computing distance is equal to the time it takes for the sound wave to travel from the sensor going to the object back to the sensor, multiplied by the speed of sound, which is 343 meter per second, and divide it by 2. We need to divide it by 2 because we use the time as overall time traveled by the sound wave, and we only need to use one set of that time, either the time it takes to travel from the sensor to the object or from the object back to the sensor. So here's a demonstration regarding the working ultrasonic sensor. So first is we put or we wire the sensor accordingly. So the red wire is the VCC input. We connect it to the 5-volt source. The black wire is the ground input. The purple wire is the trigger input. We connect it to a function gen. Then the green wire is basically the echo input. Now, we use an oscilloscope in order to view the waveforms for both the trigger and the echo. Here, the trigger is the yellow one and the echo is the blue one. We position an object at a certain distance from the sensor, and then we review again the waveform in the oscilloscope. We can see that at this distance, at the given distance, the blue waveform, which is the waveform for the echo or the channel 2, has a high signal for a limited period of time. This implies that the distance from the distance of the object from the sensor is short, and it means that it only travels a very small period of time. Now, we increase the distance of the object to the ultrasonic sensor, and we can see that the channel 2 or the blue waveform has a longer peak signal. This means that the sound wave travel longer than the previous example. And that's the end of my report.